in here. All right, today we're going to be doing assignment 27, and just want to wish, and we have no birthdays today, I don't think, but want to wish an early birthday this weekend to Nayeli, Cameron, and Adrian, who have birthdays coming up. So happy birthday, or happy early birthday. We're excited to hear from you. All right, here's what the agenda looks like. I've got two big announcements. One is housekeeping, one is about Tuesday's assignment, and you can tell from that emoji that that is a sad face announcement, but we're gonna make it a happy face. And then we're gonna do notice wonder, just as usual, and then we'll do our notes and our assignment. Okay, so big day, we're gonna make it happen. So housekeeping first. I have been noticing a trend, and I think that it's because of me. I asked you, so you are making, when you were uploading your pictures, many of you were uploading these like massive, beautiful pictures, but it was very hard to see them. So I taught you how to make your pictures smaller. But in doing so, I have noticed that some of us have started to make our pictures like very, very small. Like I can't possibly see what you're writing there. So I would love for us to follow, like find a middle ground, right? Remember, if you click on your picture, you can make it bigger or smaller. And I would just love it to take up the yellow box, right? I would love for it to take up the yellow box so that I can read it when I'm grading. You might have noticed for many of you, I've been making your pictures bigger as I grade. That's fine if you want me to do it. But some of us, I know, like to make your documents really pretty on your own. So you are welcome to jump in there. One thing I loved, this is from Kimbo's assignment yesterday, but she actually titled hers like part 1 and part 2 with two separate pictures. So if you want to go really above and beyond, this is not necessary, but if you want to go really above and beyond, then you can do that. So I'm going to go ahead and show you what I'm thinking here. This is what I think would look really, really awesome, right? Really awesome. Like here is our section, our yellow box for our notes, right? And the picture goes just to that width and doesn't go like really far beyond it, just to that width, and then continues on, okay? So that's just some housekeeping. If you want to keep doing it your way, that's okay, no big deal. I'll make it work. I'm flexible, but that would be super awesome if you could make that happen. All right. For this one. Okay, this is my second announcement. This is my like womp womp announcement. We only had 63% of our submit our assignment on Tuesday. I believe that was because the assignment was a little bit of a hot mess, right? And I will totally take the blame for that. So I did want to give shout out to the people who turned it in. Thank you for turning it in. And then for those of you who did not turn it in, I wanted to give you a little bit of an update on how you can get some different kind of support for that assignment. So I updated it in 2 ways. The first way that I updated it is on the assignment itself. So these problems were very, very hard, right? They were really hard. So what I did is I went in and I grabbed little videos, right, of us working through all of these different problems. There actually might be some of you on these beautiful videos, little videos that show you how to do each of these problems, okay? So if you are stuck on number 1, you can say, okay, I'm gonna go to this video and I'm gonna watch the number 1 video. I'm gonna go to the 3 video and watch the number 3 video, right? There are 7 videos here, and I hope that will give you a really good idea of how to get started on the problems that you do. In fact, if you are star, there are 7 problems done for you already, or like done via video, right? So even if you just watch all the videos, you could get your 7 problems. If you're on track, you would have just 2 more from the ones that are not on the video, okay? I hope that this will help to make our assignment much more simple, because I don't want us to be stressing about this assignment, but I do want us to learn about dividing radicals, right? So I wanted to provide lots and lots of support here. If you don't like the assignment version, you do have a new section on Canvas right underneath the assignment, right? So you have the Zoom link, then you have the notes, now you have the assignment, right? Underneath the assignment, you're now going to see a new box that has help videos. After class, I'm going to upload the help videos from our time together, right? So whichever problems we work on in class, those problems will be here. And you have the added benefit of the other classes as well. So if in second period, I work with different problems, that means that you'll have all of the videos available to you here, okay? That was a big announcement. Let's review. Somebody tell me in the chat, get ready with your fingers in the chat. Where can you find the help videos? Where are the 2 places you can find the help videos? Go, go, go. Where are the 2 places you can find the help videos? Assignment, yes. In the assignment directly and in Canvas, yes. On the assignment and in Canvas, absolutely. Let me ask a question I have been wondering if you guys know. Do you get any late points for turning in things late? Are there late points? Like, am I taking away points for things being late? No, no, I'm not, right? So I really do want you to turn them in. I know what, right? So I love when you turn it in on time. That makes me the happiest camper because I know that that means that we understood it, we are confident we're moving forward, right? But there are not late points. So if you are like, oh, I don't need to turn that in, I'm not going to get any points anyway, that's not true. You should turn it in. Yes, party emoji, I love it. So make sure that you are turning them in and we can get you the support that you need, okay? Are there any questions about that announcement or the one before? Any questions, any questions? All right. All right, I'm gonna jump in here. I want to start with noticing and wondering, noticing and wondering. So I have 4 colors here, right? 4 colors here. These are screenshots from Desmo. So you have your question that I typed in here and the answer that it told me here, right? So I have a red one, a blue one, a yellow one, and a green one. I want you to be thinking about one of these questions. What do you notice about these problems? What do you wonder about these problems? And which one doesn't belong? You could make an argument for many of them, but which one do you think is the one that should not belong here? Go ahead and type your answer to one of those questions or more of those questions. Unique thinks the yellow one. Unique, can you tell us why does the yellow one not belong here? What's different about the yellow one?
Because it is in parentheses and it has like a 3.
Yeah, absolutely. This one looks funky, right? It has parentheses. I see Gary echoing that in the chat. We have the 3 here and the 3 here. Okay, interesting. Can someone make an argument for a different one not belonging? What other one could not belong here? Thank you, Unique. Also shouting out Unique. I absolutely forgot to shout you out, but thank you for coming off mute. Appreciate you. Ooh, yeah, Noemi, why are you thinking the blue one that might not? Why does the blue one not exist? Can anyone make an argument for that one? Because it's a really big number. Yeah, for sure. That's a great reason why this doesn't. All right, we have a single digit 4, single digit 4, single digit 3, right? And then 1,000. That's a huge number, right? Okay. Okay, I want us to specifically look at what the answers are. So square root of 4 squared equals 4. Square root of 1,000 squared equals 1,000. Cube root of 4 cubed equals 4. Square root of 3 squared equals 3. What do you notice about that? I want to see 3 noticing. What do we notice? I've got 2 noticings. I'm looking for a third noticing. Yes, I've got 3 noticings. They all say the same thing. I love it, which is the number in the radical is the answer. Yes, absolutely. Yes, Diana. Yes, Marcy. Yes, Noemi. The number inside of the radical, I particularly love that language, Marcy. The number inside of the radical is the same as the answer. So I am starting to see here that the square root and the square must be inverses of each other. They must be opposites of each other. Does that seem familiar to us? Have we heard of that before? The radical is the opposite of an exponent. Pretty interesting, right? So square root, if I have a square root and I want to undo it, right, I can use the square. If I have a square root and I want to undo it, I can use the square. If I have a square root and I want to undo it, I can use the square. What about a cube root? How did I get rid of a cube root? The 3, absolutely. If I have a cube root, then definitely, Roxana, I can use an exponent of 3 to get rid of it, right? So today we're going to use this idea in order to get rid of square roots in our equation. Okay, so we're going to be moving to equations. I know some of us love solving equations, so today's going to be your day. But we are going to transition into our notes. Remember, you have 2 options today, right? If you think the video option is going to be better for you, you like to pause it, you like to like move at your own pace, you can choose team video. I'm going to open up your breakout rooms in just a moment. If you'd prefer to learn with me, I love that option. You are welcome to learn with me. You're going to stay in this room, so you'll ignore the breakout room. Okay. Think about which one will work better for you. And then I'm going to go ahead and open these rooms. If you want to do team video, take the breakout room. If you want to do live action, just ignore it. You can press that ignore button. You're welcome to jump into that video, especially if you're kind of laggy. I get it. It happens. If you're staying with me, I'd love you to answer a poll. How are we on timing? Do we have paper in front of us? We're ready to go. Let's take some notes. Do we need a minute to get ready? Where are we at? Where are we at? Go ahead and answer that poll. Answer that poll there as I switch over my screen here. Are you ready? Do you need a minute? Do you need 2 to 3 minutes? All right, if you're one of those people that needs a minute, hopefully you're taking it now, grabbing that paper, pencil. All right. Let's jump in. It looks like we are moving and grooving. Moving and grooving. We didn't have anyone who needed that extra time today, so I appreciate you being ready to go. If you've got a piece of paper, you're going to go ahead and title it. Title it Solving Radical Equations. Solving Radical Equations. All right. Yesterday or Thursday, we met our goal of 5 people coming off mute. I would love to up our goal to 6 people coming off mute today. So feel free to get ready to mute or unmute. You've got your mute button there. You can click it, or remember that you can press and hold the space bar on your Zoom. There are 4 steps to solving a radical equation, 4 steps. I have listed them at the top here, right? If you're someone who likes the steps, you can go ahead and write them down. If you're someone who just wants to write the steps in like a low key way, I have just the highlighted words here, right? So you can either write down the full sentence steps if you like those, or you can write down the one word steps if you like those. Okay, so the first thing that we are going to do is isolate the radical on one side of the equation. What does the word isolate mean?
To leave it
So like, oh,
Go ahead, Roxana, and then Gary.
to leave it alone.
To leave it alone. Gary?
pretty much the same thing, to have it left alone.
Yeah, to have it left alone. We could call this quarantine the radical, right? I was thinking about this last night. I was like, oh, for the first time ever, we're going to understand what isolate means, right? We're quarantining the radical. We want to get it by itself, right? We got to leave it alone. All right. Number two, we're going to raise it to a power, right? Just like we saw on the notice wonder, to eliminate the radical. So if I have a square root, I'm going to use a square to get rid of it. If I have a cube root, I'm going to use a cube to get rid of it. Okay, raising it to a power. My third step is to solve the equation like normal. And then my fourth step today, we're going to learn about extraneous solutions. Extraneous, we're going to check, right? So that last step is to check. Extraneous means that we actually solved it correctly, but the solution doesn't work, right? We solved it correctly, but the solution doesn't work. All right, so we've got our four steps: isolate, power, solve, and check. Go ahead and take a moment to write down number one if you have not already. We have 2 times square root x plus 2 plus 1 equals 7. Solving equations, love equations. All right. So the first thing that I want to do is isolate the square root, right? So the square root is here and it includes everything involved in it, right? Everything involved in it. What is not included? What is not included in the square root in this problem? Like what's on this side that I want to get to go away? Yes, absolutely, the 2. And what else?
The radical.
The radical is here. I want to leave the radical over here though. I have a 2. I want to take away the 2. The x is inside the radical. Good thought. The x is inside the radical. What else is over there? Positive. Yes, Amelia. Go ahead, Roxana.
Positive 1 equals 7.
Yes, the positive 1 and the equal 7 is already on the other side, right? So I have here the square root. That's what I want to leave alone. That's what I want to get by itself. And then I have a 2 here and a 1 here, right? So I want to get rid of the 2 and the 1. I want to move them to the other side. So how can I get rid of a plus 1 using our equation skills? What's my inverse of positive 1?
Minus.
Yes, minus 1, minus 1. 2 square root x plus 2 equals 7 minus 1 is 6. All right. How do I get rid of this 2? 2 times square root. How do I get rid of the 2 if it's multiplied? I can't subtract 2 because there's no sign here. Yes, Sebastian, I want to divide by 2. I'm going to divide by 2. When I do on one side, I have to do on the other. I'm dividing because technically here I have multiplication. Right? Technically I have multiplication, 2 times square root, right? So I need to divide in order to make that 2 go away.
Oh, so you don't you don't take away 1, 2 from the other? So you divide them all by 2.
Good question. I'm just going to divide this one by 2, right? So I'm taking the 2 and I'm dividing it away. It's not going to impact the square root because the square root is like locking the x plus 2 inside. The square root is locking the x plus 2, so it can't touch the 2. Does that make sense, Sebastian?
Makes sense. Thank you.
Of course. Amazing. We're at 3 already. I love it. All right, so I've got square root of x plus 2 equals 6 over 2. What's 6 divided by 2?
3.
3. I think I saw Jasmine. I don't know if there was a second person, but thank you so much. Square root of x plus 2 equals 3. Perfect. All right. We've got our radical by itself. We have isolated officially. We've officially isolated. Now I need to use a power, right? Now I need to use a power. I'm going to get rid of this square root by taking it to the power of 2. The square root and the square will cancel each other out, as we saw in our notice wonder, as you all told me today. So what I do on one side, I need to do on the other side as well. So I have the square root and the square will cancel. Leave me with x plus 2 equals, what's 3 squared? 3 squared.
9.
9. Yes, Melanie, thank you. It is 9. 3 times 3. And then I'm going to go ahead and subtract that 2. We get x equals 7. X equals 7. All right. We did our power. We solved it. We now need to check it, right? So what I'm going to do to check, I'm going to plug it back into my original equation here. I have 2 square root. I have an x, and I think x is 7. So I'm going to plug in 7 plus 2 plus 1. It should be equal to 7. I don't know yet. I don't know yet. I want to show you something really cool on Desmos. I know we've been doing a lot of this by hand, but I want to show you something cool since we do have a tool in our midst here. If I type in this part into Desmos, it should give me 7. So I'm going to go ahead and type it in all at one time. 2 square root 7 plus 2 plus 1. Does it give me 7? Yes, it does. Woohoo! Right, so since it equals 7 here, that means that this is correct. Notice if I had put in like 6, we had gotten 6, we would have thought, oh no, that's not correct, right? I want 7. 7 is my correct answer. So we know that this is a correct solution. 7 is a correct solution. All right, we've done a lot so far. How are we feeling? I'm going to send out this poll. Take a moment. How are you feeling about that first problem that we just did?
Would we be able to check the question the same on a basic calculator?
On a basic calculator, it depends how basic, Jasmine. If you like just have the one that only does 4 digits, then no. But if you had a yellow calculator like the ones you have at school, right, or if you have like a TI of really any kind, or I have a smaller TI somewhere in here, but you could type the same exact thing into your equation and you would hopefully get 7, or you should get 7 when you type it in. You're welcome. The calculator, you could use that kind. I have a TI 84 here. That's the yellow ones that we use at school. TI 83s, even TI 30s or 27s. Those are like the slightly smaller scientific calculator. Almost any scientific calculator will let you type it all straight in, right? So anyone will let you type it straight in. So great question. Thank you, Jasmine, for asking that. And Sebastian, I see you in the chat as well. All right, here's where we're at. Just to start out, we are like a lot of us sitting at 3s, sitting in a good place, a couple 2s, 4s, and 5s. So let's try another example and see if we can make it happen. Go ahead and take a moment to write down number 2. Just the problem, writing down this problem here. All right. My first step, can someone tell me my first step? What's my first step? Roxana would like to move the 5. Do we agree? Marcy agrees.
Yes.
Yes. Sebastian, you want to move the 5? Sebastian, how would we move the 5? -5. Yep, we've got -5. Thank you, Sebastian, putting that in the chat. Thank you, Melanie, as well. So -5, I'm going to subtract it on the other side. 5 minus 5 making 0. Square root of 2x minus 1 equals -3. -3, 2 minus 5. All right, we've got the radical by itself. We have isolated. We need to do our power, What should I do in order to get rid of the square root? How do I get rid of the square root?
Radical. We need to get rid of the radical, so it's square.
Yeah, I want to get rid of the radical, so I'm going to square it. Thanks, Roxana. Thank you, Roxana. So I'm going to square this. Right. Notice I put parentheses here. That's just because I have a minus there. I don't want to forget that it's -3 squared. Right. I could put parentheses here as well. It's not going to change. So I have my square root and my square will cancel and leave me with 2x minus 1 equals -3 squared. What's -3 squared?
9.
+9. Yes, Melanie. It is +9. Be careful. This is -3 times -3, right? Negative times a negative will make a +9. No problem, Sebastian. You're totally fine. You helped us. It's perfect. You helped us. All right, go ahead and take a moment. Solve the rest of this on your paper. I'm going to send a poll to you. I want you to choose. Is it A, 5, B, 3, C, 0, or D, -1? Choose which answer you think is correct once you have solved the rest of this problem. If you're looking for those numbers again, they're over here on the screen. A, 5, B, 3, C, 0, D, -1. Go to make that choice. All right. I'm going to go ahead and add 1 on both sides. I've got 2x equals 9 plus 1 is 10. Dividing by 2 on both sides, x equals 5. X equals 5. Our correct answer was A. Let's check it out. How did we do? Oh, yeah, nice. Most of us had a letter A, a majority, which is awesome. A few B's, a few C's, a couple I don't know. Thank you for your honesty. Hopefully, as I worked through it, got a little bit more of an idea there. All right, let's see. How are we feeling? Now that we've seen 2 problems, I am going to relaunch this. How are you feeling? Nice. All right, looking like a lot of 4s here. A lot of 4s here. Appreciate you. Many 4s, some 3s, some 5s, a few 0s. So we're gonna keep working. Go ahead and feel free to ask any questions that you have. Okay, I am going to have us work with, you know what? I am going to, for now, no, we're going to do number 3. I thought I was going to skip it, but we're not. All right, number 3, let's do this one right here. This problem here, square root 2x minus 1 equals square root x plus 1. All right. My first step is to isolate. It's to get the square root by itself. So I see that I have a square root here by itself, and I have a square root over here by itself. They are already isolated. There's nothing I can do with them, right? There's nothing I can do with them. So I'm going to go ahead and move to my next step, right? My next step, which is to, take the opposite of a square root, right? Opposite of a square root. How can I get rid of this square root? How can I get rid of it? Square it. Absolutely, Emiliano. So I'm going to square it, right? And what I do on one side, I also have to do on the other. What is very cool about this, square root and square will cancel, and you have 2x minus 1 equals the square root and the square root will cancel. You have x plus 1. X plus 1. So in this case, if we have a square root on both sides, we can actually get both of the square roots to disappear by squaring both sides. So this problem is actually a little easier. Go ahead and take a moment to continue solving this. We're going to move the x to the other side, trying to get x's on one side, numbers on the other side. Go ahead and take a moment to solve it on your own. When you're ready, you're going to answer. You have the options: A is 4, B is 3, C is 2, D is 1. When you're ready, go ahead and answer that poll. All right. Can someone tell me what was their first step? What was your first step here? Move the 1. Which one did you move, Emiliano? The negative 1. All right, so you moved the negative 1. How did you move it? Positive, yes. I'm going to add positive 1 here. I'm going to add it to the other side, positive 1. I get 2x equals x plus 2. X plus 2. What should I do now? What should I do now? Feel free to come off mute, my friends. Subtracting x, thanks, Emiliano. So I've got 2x minus 1x would be 1x equals 2. 1x equals 2. I've got my answer right here with C. Right here with C. Let's see how we did. We've got lots of C's, which is awesome. Lots of C's. If you got D, you may have just messed up with your 1s. You may have messed up with your 1. That is all right. All right, friends. I'm going to pause on our notes there. I think that is enough to get us started on our assignment. If you would like to see this one, if you would like to see number 4, you're just like, you love to see more notes. Number 4, there is a video on Canvas per usual. There always is. There's a video on Canvas. You're welcome to check that out. And so if you would like to see this one with a cube root, you can check out the video. I want to just quickly review our assignment. Remember, you, as always, get points for your notes here. So you're going to drop your notes in this box here. And you have two options today. You can either work through paper problems, as usual, or you can work through an IXL, right? So you have your numbers here. Make sure you're following the correct numbers. So you're either working on paper and uploading a picture, or you can work on IXL if you prefer that computer option. Finally, for part 2, there are 2 problems worked out here, right? One person is correct and one person is not correct, right? So you're gonna look at the work that they did and try to figure out where one person went wrong, right? One person got 9 and one person got 18. You're gonna try to figure out what did they do wrong. And finally, you have your checkpoint, right? Finally, you have your checkpoint here. So this is worth 10 points here. You have your 20 points from part 1, and you have 5 points from part 2, right? So 45 total points here, right? Can someone remind me if I need help? If I need help, I start doing this and I need help. What are my options for getting help today? What are my options for getting help today? There are many options. How can I get help today? There are videos on Canvas, yes. There are office hours, yes, Noemi. Office hours are today at 10:30, right? Today at 10:30. Come to office hours from 10:30 to 12. You can tell me, yes. You can text me, yes. You can email me, yes. So many options for getting help today. And additionally, I want to remind you there are Trojan tutors today at 10:30. So I know Jasmine and her team would love to see you at Trojan tutors. And we will make that happen, okay? I'm gonna go ahead, if you are in Miss Flores's breakout room, you can go ahead and take that breakout room now. Go ahead and jump into that breakout room now. You should see a breakout room button on the bottom. Otherwise, y'all have a great weekend and I will see you next Tuesday. I'll see you next Tuesday. Adios, my friends. So if you're in Miss Flores's group, you can jump in there. Marcy, for number 1, you're just going to solve number 1, solve number 2. You should get the same answer for both of them, right? Then when you solve number 3, solve number 4, you should get the same answer. Bye, Emiliano. Have a great day. Thank you. Adios, adios. All right, bye, friends. Amira, go ahead and jump into that breakout room. Helen, go ahead and jump into that breakout room. Josh, Liza, jump into that breakout room. Adrian, go ahead and jump into that breakout room. Jessica and Josh, you're welcome to sign off. Hello, pre-calculus. Hi, pre-calc.